Hello, everyone. I am really glad to join this session today as a postdoc speaker. In many areas of our lives, we rely on products made from high-performance materials. For example, knee implants or hip implants. Did you know that Ireland produces around 75% of world's knee implants, and the same materials are used in air agents, wind turbines, and many other advanced industries? We are talking about titanium, cobalt chrome, and nickel alloys. They're extremely tough, and also they're very difficult to cut or machine materials. And why does it matter? Because machining is a step that gives a final shape or value to the products or parts. And if something goes wrong, it can cost a lot of money or time or even wasted material. Here is the interesting fact that the tool is just a very small part of the whole machining process. And it accounts up to 4% of machining cost, but if it breaks or fails, it can lead to up to 30% of total machine downtime, increase the total machining cost, and even worse, a lot of tools thrown away too early with the 30% of remaining useful lifetime. And why does it happen? Because actually there is no clear way to monitor what actually happening during the machining and what tool is experienced. And this is a solution developed by iSentioLabs company. It's a technology for monitoring of the tool states. It consists of a passive battery-free sensor which placed at the cutting edge of a tool and connected to the antenna. And this antenna sends the data from inside to the tool to the outside. And by collecting this data, we can not only do the smart diagnostic, but also it provides adaptive control of the machining. And the core of this technology is a wireless link. Because the machine is very complex and it has a lot of moving sides, we can't use any cables. And the only way is use wireless technology for transferring data from the machine to outside. And this task is not very trivial. It's not possible to buy some antennas from the website. It should be specifically designed, and there is some specific requirements because the space inside the machine is very tight, and all machine is metal, and it's very complex environment for the signal propagation. And it means that designing such an antennas requires a specific skill set and expertise. As a person with a PhD in microwave and radio frequency engineering, I know how to handle electromagnetic waves and how to get the signal from inside the machine to outside world. And I joined the iSentioLabs company in 2022. iSentio is a small size Irish-based company focused on advanced manufacturing. We started our partnership through the Career Fit program. It's Marie Curie's team, co-funded by Enterprise Ireland, and now we continue through Research Ireland Enterprise Fellowship. For me, it was a big shift of my career from pure academic research to industrial research, and I really can feel the difference in between of both of that experience. I would say that before, most of my design were intended to be published or going for further research proposals, and now all my design are tested in real life inside the machine, and I'm really glad when tests are going pretty good. And on everyday basis, I am facing with like real world challenges, and I believe that I not only grow as a researcher based on this experience, but also this experience definitely improve my future employability. It was also a big shift a big step forward for the company because it helps to speed up the product development and also moving the technology much closer to the market, because wireless technology is actually the core of the solution. As a small size company, they couldn't afford to hire a full-time person dedicated to design wireless hardware. And it was a great opportunity for them, especially at this stage of the product development. It was incredibly important. Our solution has also impact on machining in overall because it supports energy efficiency. The solution is completely battery-free. The sensor is passive, and also it improves the digital connectivity in manufacturing and machining. And wireless technologies is not only shaping the future of the manufacturing. Actually, they're with us every day, and everyone uses the wireless technologies. Maybe very often we really think about that, but they help to improve and enhance medical diagnostics and sensing, and it's a huge development of wireless technologies for medical application. It also help our homes be smarter through IoT technologies and even move us closer and closer to autonomous vehicles. And be honest, it's only a small part of impact of wireless technologies and of its capabilities. It's quite funny that we can't see them, but they are really transforming not only our today, but also our tomorrow. And I'm really proud to be part of this field. Thank you for your attention.